Thank you very much for coming to my talk. My name is Ingo Kegel, and I'm going to be talking about monitoring versus profiling. I'm from EJ Technologies, and you may not know EJ Technologies as a company, but you may know our most successful tool, which is JProfiler. It's an all-purpose Java profiler. And so you may be wondering, why am I talking about monitoring if what we do is profiling? Okay. So the reason why I have monitoring in my talk is that we have a new tool, a monitoring tool, and in this talk I really would like to tell you the story of how we went from having a profiling tool to developing a monitoring tool. And I think these kind of stories are always interesting because they contain some insight, and they tell you why things are the way they are and what we have learned along the way. And actually, this is the first time that I talk about this new tool. And yeah, I'm happy that I'm here in Poland. We have a lot of good connections to Poland, and Poland is a real Java powerhouse, and so I think it's very appropriate that I'm here today and present our new tool for the first time and with this talk. So let's start. Let's start on the profiling side. That's what we do originally with our Java profiler. So what is the purpose of a profiler? What are the use cases? Where is it usually used? So the first use case is the most frequent and also the least exciting. It's quality assurance. You do that regularly, or you should do it regularly, and check if you can make your application better, if you can make it faster and make it use less memory. And that is done in development, that developers do that, or at least you do it in a development or a staging environment. And the second use case, the second major use case is the one of firefighting. So if something goes wrong, if you have an emergency, if your website is slowing to a crawl, and then you have to do something, and you bring in the profiler to solve the problem. And that is also done by developers, because they are the ones who can fix this. But the problem is, it's not done in a development environment, it's done usually in a production environment, because that's where the problems occur, and you often cannot replicate these problems in a development or a staging environment. And that is a problem, because a profiler is not designed for that. The profiler is not designed to be used in production. And here you have a trade-off. The problem has to be so serious that you can bring in the profiler, disturb your production setup so much because you need the information of what is wrong so that you can fix it. So profiling in production. What is our point of view with respect to profiling in production? Of course, we cannot say profiling in production is something that we do not recommend at all, because it's one of the major use cases of a profiler. You need it in a firefighting situation. But we say you should avoid it if possible, because a profiler is not optimized for that. A profiler is optimized for maximum insight and not for minimum risk. And what you should do instead is you should use a monitoring tool, because the monitoring tool is really optimized for minimum risk and for minimum overhead, and that is what you need in production. And you should use the monitoring tool by default, and then bring in the profiler if there is an emergency when the monitoring tool cannot help you anymore, and the profiling tool will be used in those cases. But the problem with that is that our customers, a lot of our customers, don't do it that way. They want to make the profiling tool, the profiling agent, as part of their standard production environment, have the agent running all the time. There are lots of people who do this, and we don't really like it, but they do it anyways. And Then lots of questions arise. For example, what is the stability impact? And there is a stability impact. There are lots of XX options to tune the JVM that do not work very well with the profiling interface of the JVM. What is the overhead? Is there overhead? Of course there's overhead. With a profiler you can create a lot of overhead if you configure it in such a way. And of course you don't want that in a production environment. And then there are questions also that go towards features, like how do we get historical data? You can do that by adding triggers and then saving snapshots periodically and then using command line tools to extract data and build a timeline. But you can see that it's not meant for that. And also clustering, what do I do if I have multiple JVMs? How to merge the data? You can't, because the profile is a one-on-one thing. You monitor one VM at a time, or you monitor multiple VMs in multiple windows, but you don't get an aggregated view of all the VMs. So this shows that it's actually a bad idea. You should not do it that way. But even though it's a bad idea, it shows that people have these fluid real-life use cases, or more in particular, they have a wide range of use cases. And the monitoring use case and the profiling use case, those are two categories which are on the opposite ends of a spectrum. And some people have their own special problems, and sometimes you fall in the middle and you need capabilities from both sides. You need monitoring capabilities, you need profiling capabilities at the same time. And so this is really a gap in the tooling that is not really catered for at this time. And so this, for us, presents an interesting opportunity or an interesting possibility. Can there be a combined tool? Can we make a tool where we have monitoring and profiling features in a single tool? Is that possible? Or more specifically, because we already have a profiler, can we add monitoring features to JProfiler? Can we make it into a lightweight monitoring tool, so to speak? That might seem like a good idea from a business perspective, to just add a little more functionality there and then also cover some of the monitoring market. But in order to answer this question, if this is possible, we need to analyze the technical foundations. And before we look at the technical foundations, let's look a little bit at why the technical foundations are different in these two environments, in production and development. So as I said, profiling is done in development and monitoring is done in production. And production comes with all these constraints on stability and overhead. Like for stability, if we look at the stability side, for example, let's just take an example. There is a garbage collector that is frequently used, the CMS garbage collector, which does not work with the native profiling interface of the JVM. And if somebody in production decides to tune the garbage collector and use the CMS garbage collector, then your JVM will probably crash, not right away, but after an hour or so, and you won't know why. And so this is a dangerous thing to do, to use this kind of functionality in production. And the same thing goes for overhead. In a development environment, you don't care about the overhead. If you need to solve a particular problem, you accept 100% overhead without any problems, or 20% overhead, you don't even think about it because you want to find out what the problem is. But 20% overhead in a production environment is a disaster. You cannot do that. So for the technical comparison, I would like to focus on two different aspects. The first aspect is how data is collected and what data is collected. The how side is more related to the stability question, and the what is related to the overhead. So let's look at how data is collected. So when you look at the data that a profiler represents, that seems a little bit like magic. Where does the profiler get that data from anyways? With magic, I mean things that you cannot write into your Java IDE to get this information. Obviously, there is no API in the JVM to get all the stuff that a profiler displays. And if you want to do something without this magic, you have data from JMX, MBeans that are published by the JVM and give you some useful data so that you can know what's going on in the JVM. And JMX, yeah, you can build a tool around that. But the problem is it's not enough for solving the two most common problems that people have, and that is solving memory leaks and solving performance bottlenecks. And if you want to go further, then you have to use the kind of magic that the profilers use, which is the JVM TI, the Java Virtual Machine Tool Interface. And that's an interface in the JVM that we have since Java 5, and before we had an experimental interface, JVM PI, which was quite buggy and slow, and we're very happy that we have the JVM TI now, and it's really well tested, and it's reasonably sane to work with, so that's a great thing in the JVM that this exists, and other environments don't have something like this, so this is really one of the key advantages of the JVM as a platform. And what you have to know about the JVM TI is that it has two parts. It has a native part, that's the larger part, that's where all the juicy stuff is that the profilers use. And it has a pure Java part. And yeah, you can, when you're loading an agent, you can immediately see whether you're using the native side or you're using the Java side. If you're using the native side, you have an agent path VM parameter, and if you're using the Java side of the JVM TI, you're adding a Java agent parameter. So the pure Java part of the JVM TI is really very small. It's just mostly concerned with instrumentation. And the native part is where all the extensive functionality of the JVM TI is located. So profilers, to get all this data, they use the native JVM TI. And what does that mean if you use the native JVM TI? What does that mean for the running JVM? It means that the JVM is not running in its normal undisturbed state. And the JVM TI is an interface where you can request capabilities from it. You can say, I need this, I need that, and I need that functionality, that feature, I have to be notified of the following events. And the more you request from the JVM TI, the more you disturb the JVM. The JVM then cannot optimize certain things. The hotspot compiler cannot remove certain methods. The JVM has to accommodate inconvenient data requests at inconvenient times. And so this is all not running in the way that it is usually tested. And it does disturb really the way that the JVM runs. And also, because you have access to a lot of data, you can process a lot of data and potentially store a lot of data. It can potentially create high overhead. And the third thing is, it's a native interface. It's not an interface that you call from Java code. You have to call it from C or C++ code, from natively compiled code. And that means that you load native libraries. And of course, I mean, that's it's always more risky to do native programming, but let's say you don't have any bugs in your native library. Even then, you have a stability risk, because there's lots of external factors where the JVM TI will crash. So it doesn't crash in your library, but it crashes in the JVM TI because you're using some tuning options for the JVM that do not play well with the JVM TI. So it's a risky thing, and if you have a bug in your Java code, then it prints an exception, and you can potentially recover somewhere. Or, but in this case, there's a seg fault, and the JVM is gone, and that is something that we don't expect anymore from a JVM, and makes us really nervous if something like that happens. So this kind of leads to the conclusion that you cannot use the native JVM TI in a monitoring tool. It's not good. You cannot do that. And if we don't have the native JVM TI, what happens then? What can we not do if we don't have the native JVM TI? The first thing we cannot do is we cannot do native sampling anymore. What is sampling? Sampling is the way we usually gather information of what is happening, what methods are called in the JVM. We halt the JVM periodically by using the the native JVM TI, and inspect all the call stacks of all threads in the JVM. And from that, we build up the call tree. And that is, of course, core functionality for solving performance bottlenecks. And if we don't have the native JVM TI, we cannot do this efficiently. There is a possibility to do something like this in pure Java code. You can write a timer and inspect call stacks of threads, but that adds very high overhead and it disturbs the JVM even more than what you do with native JVM TI. So that's far worse doing it in Java code than doing it with a native JVM TI. That's one thing. And the other thing is we don't have any deep memory data anymore. With deep memory data, I mean relationships, references. There is some shallow data that we can get from the JMX. You can get lists of classes and we can get numbers of instances for each class, but we don't get the relationships that would allow us to find out why objects are not garbage collected anymore, why there is still a reference to a garbage collector route. That is not possible if we don't have the native JVM TI. So that's pretty bad because it prevents solutions for these two most common problems that I mentioned. It prevents the solution for memory leaks and for performance bottlenecks. So that was the how. Now I'm looking at the what. What data is collected? If we look at profilers work on a method level. They look at all the method calls in the JVM. Or let's say they don't look at all the method calls, but they look at a sizable subset of the method calls in the JVM. And that is a problem. Why is that a problem? Because the number of method calls in the JVM is staggering. It's much more than you would intuitively expect. And you have to be extremely careful what you do with this and how many things you intercept and store and instrument, and also with sampling. It's difficult. It really is the major overhead factor. And you can tune it. You can say, okay, let's just look at the high-level method calls, at the ones that take a couple of milliseconds at least. And then you get your overhead down. You can even make the overhead very, very small by really choosing the right packages. But that is not good for production, because it requires tuning, and that tuning can be broken at any time. You just rename your packages, or it just requires a very simple change in your application, and the tuning is gone. So, yeah, that's how Profiler works. And monitoring tools don't do that. Monitoring tools have this high-level requirement baked in directly. They don't work on the method call level. They work with business transactions. And of course, they also look at method calls, because that's the only way you can really find out something, by inspecting method calls. But what they do is they instrument very selectively. They know which methods are interesting. Like, they look into certain subsystems that give interesting data. And they collect high-level data. They don't just say, okay, this method was called, but they inspect the context. They look at the parameters. They potentially look deep down into getter chains or something like that. And they have more information on what's happening. And with this information, they can then construct semantic names for these business transactions that tell you what is actually happening from a high-level business perspective. So that is very different from the data that is collected by a profiler. And what this shows us altogether is that there is really no common basis. The how is too different, the what is too different, and there is really no way that we could unify the monitoring and the profiling side and put it on a common foundation. So, is this now the end of the discussion? Obviously not. There's something that we can do, but it's different from what I said in the beginning. What we should not do is not take a profiling tool and try to move it into the monitoring space, but we have to do something else. We have to go the other way. We start with a monitoring tool, and from the monitoring tool, we add crossover functionality towards the profiling side. And that works a lot better than the other way around. And of course, the profiling functionality will then not be part of the regular setup, but it will be used for the emergency cases where you need to find out more. And that is really the strategy that works very well. So this led to our new tool, which is called perfino. And in the rest of the talk, I will be talking about perfino. I'll also show it later on. Perfino is a relatively new tool. It was released in May of this year. It's at version 1.0. And it's an APM tool, APM, Application Performance Management. And what we did with perfino is we retained some of the concepts, of the successful concepts that we developed in JProfile and brought them to the monitoring space. And we added this, as I said, this crossover profiling functionality for the emergency cases. Now, the bulk of the functionality in perfino is really monitoring related. But in this talk, I'm focusing on the crossover functionality, the crossover towards profiling. So it's not really weighted appropriately. There is a lot of monitoring functionality that I'm not going to discuss. So what of the concepts in JProfile have we brought to perfino? Over the years, we have seen that users are very comfortable with the following things in JProfile, especially call trees and hotspots. That's something that is easy to use and is very useful to use, and you can really work with it to solve problems. And in JProfile, the call tree, as I said, it's built on a method level or on a class or package level as you move to higher aggregation levels. But it's fundamentally always based on method invocations. And in perfino, we do the same thing with business transactions. We nest business transactions and build a call tree from those business transactions. And then we can also build hotspots, because hotspots are really just the inverted view on the call tree, where you can see what methods take the most time, and then when you open them in the tree, you can see the back traces and see where the calls are coming from. So this is not bringing in a lot of overhead. This is just a different way to organize your data and view the data. So let's go back to the crossover stuff and look at memory first. There's not so much I can offer for memory, so I'll do that first and come to more interesting things later. As I said, if we don't use the native JVM-TI, we don't have this kind of data that will allow us to solve memory leaks. But it turns out there is one thing that we can do. We can ask the JVM to save an hprof heap snapshot. That's functionality that is directly in the JVM that can be executed very safely. There are command line tools to extract that data. There is a VM option that allows you to save an hprof snapshot when an out-of-memory exception occurs. So that is something that you can do really without worrying too much. And what perfino does is it provides you an easy way to record such a snapshot and transfer it to your local machine and then hand it off to JProfiler, where you can then use the heap walker in JProfiler to analyze the data and to find out where the memory leak is. So that is more of a convenience thing using existing functionality, but it still solves the case perfectly because that's all the data you need, and you get it at basically no cost in stability and continuous overhead. The second thing is performance bottlenecks. That is a little more complicated. And what we did there is we introduced a sort of intermediate native sampling mode. We built a separate library for perfino, which has no common technical basis with what JProfiler does. We thought really hard about the minimum required capabilities to request from the JVM-TI and concurrency issues and all that stuff to make it really production proof. And that native library can be loaded on demand. So you still use it in the case of an emergency, but that emergency is now more of an annoyance. You can use that on a far lower level of urgency than you can do that with the entire profiler. And yeah, that's what the native sampling does, it saves snapshots that can then be opened in JProfiler. And the interesting thing there is that you have both the monitoring side and the profiling side in the same snapshot. You see the top level business transactions, and below that you see the method level sampling. And that is a really useful crossover point where you can bring this information together from both sides of the spectrum. And in the case of a total emergency, there is still the possibility to work with JProfiler, and Perfino helps you by detaching the VM, loading the JProfiler agent, and telling you you can connect to it on that port. So that is something that that is still available and is the sort of last resort. So what we have now is actually 3 levels, which we call defense in depth. So in the first level, you have the monitoring level. That's what is always on. Gives you useful information, helps you solve lots of problems. But there are cases where you cannot solve your problems with pure monitoring functionality. And in that case, it goes to level 2. You can load the native sampling library, find out a lot more information about what is happening in the JVM, and then solve your problem with minimal impact to your JVM. And in level 3, there is the emergency where you need everything at your disposal and to throw at the problem. And that is the detached for JProfiler. And I think that that picture really summarizes the entire crossover perspective that we have developed with Perfino and JProfiler. Yeah, and as far as slides are concerned, I'll leave it at that, and I'd like to show you some real action now. So let's try this. And to move this to a different desktop. There we go. Oh, it's kind of difficult now without a remote control. Try it that way. Okay, here we go. Oh, that's a good idea. Helps a lot. Okay, so let's log in. Great. So this is a demo server that monitors a couple of, it's running locally here. I don't have any internet connection right now. You can see that on our website as well. It's the same thing. It's a couple of JVMs that are monitored just for the sake of providing some data that so you can play with the with all the views in Perfino. It's real measured data, but they're not doing anything useful actually. They're just producing mock data, so to speak. And you can see they're organized into various groups. The group here is the configuration unit. You can apply different configurations for each group. And the only thing you do to monitor a JVM is you add the Java agent VM parameter. And with the Java agent VM parameter, as I told you, you can see that you're not using any native library. We're not using the native JVM. That's all pure Java code. So let's look at one of these JVMs in particular. If we click on the show button here, it takes us to the VM data views and shows us a more data for that single VM. So let's look at the stuff that I've shown you in the slides. Let's quickly look at memory. We can get this shallow data that I've told you from the JMX. The loaded classes and the numbers of instances. If I take a new snapshot, you can see this. You know this from profiling tools. Every profiling tool has something like this, where you can see the list of classes and the instance count. And so this is very cheap. We can do this without using any magic. And But this will not help you if you have a real memory leak. You can see that you have a memory leak in there probably, but you cannot really find out why that is. And if you need to do this, you go back to the VMs view, and then you say save a memory snapshot, and that will trigger the hprof snapshot that I've talked of, and it will do that, and it will send the snapshot to the inbox, which is a list of personalized messages, and from there you can download that file and save it to your local file system, and then open it with JProfiler. How's that going to work now? It's on a different desk. Oh no, here it is. Okay, great. Okay, and then it does analyze the snapshot, and you can then use the heap walker to find out what the problem is. You can then answer all these questions like, why is there still a path to a garbage collector route for a particular object that I think should be garbage collected. Stuff like that. So that's the memory side. Let's look at the CPU stuff, the business transactions that I've told you about. As you can see here, I've said we have a call tree and we have hotspots, and here I show you the call tree of those business transactions. And here you can see this naming. These are not method calls. These are semantic names, and the business transactions are ordered into such a call tree, just like you know it from a profiler. And the business transactions here are of different types. You have URL interceptions. These come from annotations, where you annotated something with a special perfino annotations in your code. There's all kinds of business transactions that we have here, and you see that the business transactions are also tracked across JVM boundaries. You can see this is all in the same JVM, and here it goes into a different JVM, and you can follow that call into the different JVM and look at the business transaction call tree in that other JVM, and here it still goes into yet another JVM. So you can do that. You can go back and forth and follow all this, all these calls. And if you're interested in the entire picture, then you can look at the call graph, which will show you more detailed information on these business transactions and how they are go from one JVM into another. Okay, so that's that. We also have hotspots, where you can see the business transactions that take most time, and when you open it, you get back traces to see where they're coming from. So that is very similar to the way that we show method calls in JProfiler, only that we have this now in a monitoring tool with business transactions. That's one of the innovations that we have here. And we do have, I said we don't have native sampling by default, but we do have is the Java sampling that I've talked before, the pure Java sampling that you cannot do really on a permanent basis. And we do that very rarely, very, very rarely, like for a particular business transactions every 30 minutes or so you can configure that. Or let's say for a business transaction that is running far too long and we have determined that it violates our policy, and then we start sampling it to find out why it's running so low. And if you click on the method samples action here, it takes us to the sampling view and shows us for this one particular selected business transaction method sample. So here you have method data. It's all very cramped here. It's a small display, but you can still see something. So this again has call tree hotspots and all sorts of payload data that's associated, like SQL strings and stuff like that. And it's for one transaction. It's only for this transaction that I've showed. It's very transaction centric, and it's for a single transaction. So it solves some problems, but there's a large number of problems that it doesn't solve. Because it's such a narrow window that we get here. And if you cannot solve your performance bottlenecks with this method, what you can do is do the thing that I've talked about before, is to bring in the native sampling library that we have. And you can do that for the VM by requesting it to record fine-grained CPU data in profiling mode. And we can do that for a number of minutes or hours or seconds. Let's do it for 10 seconds because we don't want to wait so long. And it's very similar to the memory snapshot in that it will deliver a snapshot into our inbox that we then again open in JProfiler. So it's kind of the same process now. I have to wait until that is done. Okay, here it is. And we take this CPU snapshot and download it again and open it with JProfiler. So let's see if it still comes up on the same display. Here we go. Okay. And what you see here is very interesting because here you can see the business transactions with their semantic names, the same ones that you've just seen in the perfino interface. And below them, you can see method level data. And this is now for the entire JVM. You can see in the threads view here, this was exactly 10 seconds. You can see the thread states here, all the threads. And it's cumulated information. And by looking at the hotspots, this is usually the first stop for finding out where a performance bottleneck is. You can immediately find out what the problem is and where it comes from. Also in the hotspots view, you have down here the business transactions that trigger a particular hotspot and how they contribute to the top level hotspot. So that is the real crossover point here between the method level data and the business transactions. That is what I was talking about before in my slides. So let's close this and go back to Perfino. And now I've done this manually. I've clicked for one VM on this actions button and said, okay, let's record some data. Let's save a memory snapshot. But that's not the only possibility. What you can also do is do it automatically by defining a trigger. You can say when a particular threshold is violated, if something goes wrong, do that automatically. So basically create a rule for when Perfino should do this automatically. And we can choose a threshold. I've configured 2 thresholds here for this particular group. And then tell it here to save a memory snapshot and record fine-grained CPU data. And then it will do that automatically whenever it hits a particular condition that it doesn't like. So you have both modes. You have the automatic mode where it will create this data automatically, so you don't have to sit next to it and wait for something to go wrong. And you can do it manually for when you see that something is not right. Okay, so that's that. And then finally, of course, there is still the possibility that you want JProfiler, that you need everything you have, and that is the detach for JProfiler, where you can tell Perfino to load the profiling agent from JProfiler. This is totally separate thing. You have to place JProfiler next to the Perfino agent, extract it there, and then Perfino will pick it up and show you this message. And then you can connect with JProfiler and take it from there. And that is the third level in this defense in depth slide that I had on before switching to the live demo. So I'll leave the dashboard on here, and that's as far as that's what I have, and I'd be very happy to take any questions that you have.
So how do you know if something is what is exactly the business transaction? Is it like any page access, for example, for web application? Do you track like every page request, or do you need to enable it for specific ones, or how the ones that you showed us? How do you track those?
Okay, yeah, that's the main. Let's say that's the main configuration, or the main functionality in the monitoring tool revolves around how can you configure business transactions? I've not shown you that, you're right. And let's look at this demo group here. And here you can see that. There's different types of business transactions. One of them is web requests. And you can see here that I track all web requests here. Don't have to do that. I can track only certain web requests. And you can have different configurations for different filters. So let's look at this one. Oh, that is too small. The screen is too small for me. Okay, we can still see something here. Oh, that's an old configuration. Okay, and then I can construct the naming from the intercepted URL with things like URL segments, a query parameter, regular expression group, or fixed text. So you can build the naming from parts of what you intercept, and that's the same for other business transaction types. And a very interesting way to create business transactions is by using the annotations. So you can annotate a particular method that you think is a high-level method that creates interesting data. And then with our annotations, you can already configure that naming. You can tell it, take the first parameter and then call a particular method, and the result of that method then call toString on it, and then place that into the name, and then something else, and so on. And you build this entire name from the context of a method invocation.
But is it very performance? How does it influence performance of a production server? Can I have like all my requests enabled? How does it, or do I need to really narrow it down?
No, the performance overhead is very, very small. So for one of these transactions, we have like 50 nanoseconds overhead or something like that. It's really nothing. So that was one of our key requirements, of course, that there is no overhead, basically. So you can, of course, I mean, there is always the possibility to abuse a system. If you use the annotations in particular, you could go and try to annotate lots of things that are called very, very frequently. Then, of course, you could start to build up something for very, very highly frequently called methods. But usually you don't. And if you're staying in these high-level activities like the invocation of a URL, then the overhead is zero. I can't say zero because it's wrong, but it's effectively zero, let's say.
Okay, so I can have it like always enabled.
Yes.
For all your
Yeah, that's the idea. Like with the monitoring tool, don't worry about the overhead, there is none.
So I have a question. So once I have this monitoring up and running, then I have like some JVM parameters, everything will be working fine, right? Or there will be some X and X parameters or any kind of parameters on the JVM level not going to influence the monitoring, right?
Yeah, that's a good point. Yeah, you don't have to worry about anything with the monitoring because it uses just the Java part of the JVM TI, which is basically the only thing it really does. It gives you a chance to instrument the classes. So it passes you the raw byte array of a class before it loads it, and then you can like read it yourself, modify it in some way, and pass it back and say, okay, that's now the real class that you have to load. So that's the hook where we insert things. And only instrumentation that does not have any kind of negative, there is no negative influence of VM parameters onto that. There's no risk associated with that.
Does system notify about any problems in runtime? So I don't want to watch constantly on a web page, and then I want to be informed by system.
That is a good point. Yes, that is a good point. You can do that. It's mainly in the triggers functionality where you can say like something is running very slow, or you have to be more flexible. Like everything is sometimes running slowly because of something that only happens once. You don't want to be notified all the time. So you can say like if it's running slowly more often than 10 times in an hour, for example, please send me an email. Or something like that. So here, with such a trigger, you could say, send me an email, or send something to my inbox. So when I occasionally look into the console, then I will see, okay, that's a condition that has occurred that I have to do something about it. But yeah, that's basically. There is a lot of things that we still have not done in Perfino. It's version 1.0, and we already have our plans for version 2.0, and all the interfacing with external systems like API or RESTful stuff, where you could access all this data. That is not yet implemented, but you can send out emails and be notified of when something goes wrong. Yeah. Yeah, that's a very good point, because some people don't want to change their code, or sometimes you can't change it. You want to monitor something that's in a jar file where you know what the source code is, but you don't want to recompile it. That's also a possibility. And let me see. Can bring this up again. Transactions. So what we have is something called DevOps annotations. Those are the annotations that you put yourself into your own source code and create business transactions from that. And then we also have something that is called POJO invocations, which does exactly the same thing as it mirrors the functionality of the DevOps annotations, only that you configure everything here in Perfino. So when you add a new POJO invocation, you can then tell it. Unfortunately, I cannot go to the next button here. So it's just the first screen here, and then there would be other screens. Allow you to configure the invocations that will be intercepted and how naming will be constructed. But you can do all of this in the Perfino UI without changing your source code. And there's other stuff here, as you said. You can other subsystems that Perfino already knows about, like RMI calls, or their Spring Service invocations and EJB invocations that Perfino knows about. And we're planning to add more of these features. There is, especially in the web frameworks, there are systems that don't use URL invocations anymore. Like, for example, if you have a Vaadin application. This is a Vaadin application, for example. If you have a Vaadin application, you have usually, if you configure it that way, which is advisable, you have a WebSocket connection, and all the stuff goes through the WebSocket. You cannot intercept, the URL interception is not interesting, because you get one URL invocation in the beginning, and that's it. And the rest goes through the WebSocket. So there has to be more sophisticated stuff. You can do that. With the POJO invocations, you can dive into the Vaadin code and then intercept stuff there. It's possible. We also do that, but we would like then in the future to offer these frameworks as a standard component where Perfino immediately knows about it when it's running.
So what is the cost of it?
Oh, that's a good question. Yeah. Yeah, it's you know, I mean, we have competitors on the market which are very, very expensive, and currently our strategy is not to like go around selling this tool, because this is like more a tool that you could also sell to ops people and not to developers. But we're trying to appeal to developers and not incurring all this sales force that our competitors have. And so yeah, we have different pricing, like for the first VM that you buy, and then additional VMs. So it's I don't even know the exact price right now. So it's like $1,000 for the first VM, and then $500 for the additional VMs, which is like an order of magnitude less expensive than our competitors.
How you can connect this Perfino to our web server application? What is the way? What we need?
Okay, so it's very easy actually. The only thing you have to do is you have to add one VM parameter to it. So yeah, let's say something like this. You have Java agent, and then you reference this perfino Java file, and that's it. And then of course, I mean, this assumes that it's running locally, which will not be the case in a real installation. So let's take the remote option. And then you tell it where the server is. You provide the server as an option, and the group as an option. If you have many VMs, you can have many VMs and place them into different groups. Then you tell it what the group is. There's a sort of an ID for the configuration, and that's all. Then you're connected and you're good to go. Yeah, we're doing this quite openly. Let's say we have a demo version where you can look at it, and we have a trial version that you can download and works for 30 days. And of course, you can evaluate it longer if you need to. There's no problem. But yeah, we don't call you or like come to your place or so on. We don't do that. Okay, well, thank you.